Okay, so let's go for our next topic, and it's a very simple topic, that is two-dimensional and three-dimensional box. And in this topic, we will just see how degeneracy will come into picture into quantum mechanics and how we will calculate the degeneracy. And this degeneracy is due to parameter of a system. So before going to the two-dimensional and three-dimensional system, let me give you the some analogy and we will work on that particular analogy. So suppose I have a coin and I have a dice. So what will be probability that I will get head on a coin? That is half. What will be probability that I will get 6 on a face of dice? That is 1 by 6. Yes, any number of the dice, we can get the probability, same probability 1 by 6. So if independently, we are just talking about that getting the head on a coin and getting the any number, let's say that number is 6 on a face of dice, we have probability 1 by 2 and 1 by 6 respectively. And these two events are basically what? Independent event. ये दोनों event कैसे event है? Independent event. So now we are making another experiment where we are just tossing the coin and dice together. And what we want head on a face of coin and 6 on a face of dice. So what will be that probability? Anyone?
1 by 2 into 1 by 6.
1 by 2 into 1 by 6. Okay. So if you are talking about for the coin perspective, so probability of getting head is all about 1 by 2. And if we are measuring the thing from the dice perspective, then this will be probability of getting number 6 is equal to 1 by 6. Now we have two independent events simultaneously, and we are getting probability of getting head and comma means hand, and 6 is nothing but probability of getting head into probability of getting 6. And this will be 1 by 2 into 1 by 6, that is 1 by 12. So what you have? You have a wonderful explanation that if your event is independent, the getting head on a coin and getting 6 on a dice is entirely independent event. So if these are independent event, then the combined event will be nothing. The probability to getting the combined thing will be nothing but the direct probability, multiplication of probability of getting individual or independent event. So this will work here. So suppose we have two independent variable, that is x and y, and suppose this is your probability density. X and y are two independent event, you can say. So x, y, and here we can go for dx into dy, isn't it? And this is what? This is probability to find the system between x to x plus dx and y to y plus dy. So this can be easily written as rho x as a x dx and rho y as a y dy. लिख सकते ना? Because x and y are what? Independent event. So we can separate x part and we can separate y part. You can write in this way also, probability of getting x and y is nothing, the probability of getting x as well as into the probability of getting y. So it's a wonderful thing. If your outcome is random, and if you have more than and your event is experiment have more than one variable, and these variables are random and they are independent to each other, this is very important, then probability to getting the combined event is nothing but equal to probability to getting the first event into probability to getting the second event. You can direct multiply the thing. So if this can be happen to your probability density, then we can go for this particular as my wave function also, something dx dy, and we can go for this, and this can be written as something like mod x square dx mod y square dy. Obviously, this is from minus infinity to plus infinity. This is also from minus infinity to plus infinity, minus infinity to plus infinity. And if this wave function is normalized, then individually, this wave function must be also normalized, and this wave function must be also normalized. Everyone is comfortable right now? If this is going to be 1, suppose this is normalized, because mod psi square is probability density, then this is 1, then obviously this must be also 1, and this must be also 1. So this is all about wave function. So what we can do, if you can write the probability density something like this, then you can write your wave function psi xy, and which is basically related to two independent event x and y, that will be equal to x and into direct product of x. X is a wave function associated to with x, y is the wave function associated to y, and the total wave function is nothing x wave function into y wave function. So you can have this sort of argument. So your total wave function is nothing but the direct multiplication of a wave function related to individual degree of freedom. And degree of freedom is nothing but it will tell you all about the independent motion. So we can use this particular thing. यहाँ तक clear है ना?
Yes, sir.
Okay. And what will happen to energy eigenvalue? So in the energy eigenvalue, we know that energy eigenvalue is a scalar quantity. So energy eigenvalue, the total energy is equal to energy associated to the x degree of freedom plus energy associated to the y degree of freedom. So what you have learned, and x, we cannot say energy in the x direction or energy in a y direction. You cannot say this thing because energy is a scalar quantity. So direction is not an appropriate word. So what you can do, you can say that x is the variable. It will tell you about the some degree of freedom. So Ex is the energy associated to energy with the that degree of freedom, and Ey is the energy associated to the y degree of freedom, and total energy is the direct sum, and total wave function is the direct product. So this will work, और इसके थ्रू हम अपने प्रॉब्लम को बहुत ही इजीली सॉल्व कर पाते हैं. क्लियर है ये? आपने ऐसे भी देखा होगा, सपोज आपने थर्मो फिजिक्स में पढ़ा होगा, द टोटल एनर्जी is equal to translation energy plus rotation energy plus vibration energy. So translation energy will tell you about the one different type of degree of freedom. Rotational energy will tell you another type of degree of freedom, and vibrational energy will tell you another type of independent motion, and which has associated with some degree of freedom. So similarly, our energy is direct sum related to each and individual degree of freedom, and wave function is direct product. So let's try to solve how we can solve this type of problem. I am just going to solve one system, particle in 2D, and it is very simple. So, and after then analogically we can find the answer to the another type of system. But yes, mother of all concept is that total wave function is the direct product of wave function related to each degree of freedom, and total energy is nothing but the direct sum related to individual or independent degree of freedom. And you will also see the number of quantum number we are going to use is nothing but the number of degree of freedom we are getting in a classical mechanics. So in a one-dimensional, how many quantum number we have used? One-dimensional free particle. We have used only one quantum number because there is only 1 degree of freedom is there. So if you have 2 degree of freedom, then you will use 2 independent quantum number. And obviously, degree of freedom will tell you all about the independent motion. So quantum number associated to that degree of freedom will also tell you all about the independent degree of freedom or independent motion, and that have independent information. So if I am using nx and ny, nx has independent information, ny has independent information independently. The quantum number is all about it is getting some information within itself, isn't it? So let's try to go for a particle in two-dimensional box. It's a very simple, quite easy, and this is favorite topic for JAM examination. And every year at least one question will come for the JAM exam. In NET exam, they can get in the GATE exam, they can surely give some question, but in NET exam, not a lot of questions, but it will be used into the degenerate perturbation theory and all this thing. Okay. Chalo. So let's try to go for potential xy is 0, where x is between 0 to a and y is between 0 to b and infinity otherwise. So if we want to plot this potential symmetrically, this is my x, this is my y, this is a, this is b, and outside all this region we have infinite potential. So you can assume in my hand in this plane we have x and y, and on this particular axis we have potential axis. Okay, so this is your potential axis. Okay, and we have the particle is free inside this particular box. So particle is still free particle inside this box, but we have to, and we know all the nature of free particle. Okay, so I'm not going to discuss it again and again, but let's try to go for what is going to happen quantum mechanically. So quantum mechanically, we have to solve h psi xy must be equal to E psi xy. Okay. And obviously, outside this box, the wave function is 0 because potential is infinite. So we are solving into this particular region where particle is almost free. Not almost free, it is actually free. So what is this h? This h can be written as minus h cut square upon 2m. And now we have to use del square psi xy is equal to E psi xy. And del square is nothing but the Laplacian. So we have to solve this partial differential equation. So this will be, can be written as 2m del square psi upon del x square plus del square psi upon del y square is equal to E psi xy. Now again, the independency will come into picture. So if x and y are independent, which is actually independent, then I can write psi xy must be as a function of x as a capital X as a function of x, capital Y as a function of y. And then when you will use this thing, this partial differential will easily break down into the total differential. And this method is very famously known as what? क्या कहते हैं इसको?
Variable.
Variable and separable. Very good. So what you can do, you can write minus h cut square upon 2m. This is partial with respect to x. So my y is constant. So d square x upon dx square plus, again I will go for minus h cut square upon 2m. We can give it into bracket, and this value is equal to x. D square x upon dx square is equal to e, x and y. What we will do, we will just multiply x here and divide by x, multiply y and divide by y, and we can equate the coefficient of x, y on both sides. So when we can do it, then we have minus h cut square upon 2m, 1 upon x, d square x upon dx square plus minus h cut square upon 2m, 1, sorry, this will be, क्या लिख रहा हूँ, y and y square, d square y dy square is equal to e. And now you can see this is only function of x and this is only function of y. So independently we can give some number for, and this is energy. So this is one form of energy. This is another form of energy. Obviously, this energy is associated to x variable. This energy is associated to what? Y variable. So let's try to solve this equation. So what I can put this whole thing. इसे हम क्या put कर रहे हैं? This whole thing is ex and this bracketed term as equal to ey. Okay. So that's a very simple derivation. So we can put minus h cut square 2m d square x, and 1 upon x is also here, dx square is equal to ex, and similarly minus h cut square upon 2m 1 upon y d square y dy square is equal to ey. So I will just solve once and I can give the, according to first solution, I can give the solution of second one also. And the beautiful part is that ex plus ey is equal to total energy E. This is all over here. So let's try to solve this equation. And obviously we have boundary condition, we have all the basic information of one-dimensional system. Okay, and now this is exactly the same differential equation we have used to solve into Schrodinger wave equation for the one-dimensional, isn't it? है ना ये? D square x dx square plus 2m ex upon h cut square x must be equal to 0, and we can write d square x dx square, and I can put this is nothing but kx square x must be equal to 0, and x can be written as ax e to the power I kxx plus bx e to the power minus I kxx. So now we can use boundary condition. What will be boundary condition here? क्या होगा boundary condition? बताइए. Anyone?
X is equal to 0 पे.
X is equal to 0 पे, small x is equal to 0 पर wave function क्या होना चाहिए? Vanish होना चाहिए. So
0 होना चाहिए.
0 होना चाहिए. So that will be 0. So you have ax plus bx. So from here, bx is nothing but minus ax. So my wave function is something I can take ax e to the power I kxx minus e to the power minus I kxx. What I can do? I can write this thing in a sign form. So we can multiply with 2i, and what I will get? C sine kxx. So this x is basically C sine kxx. Are you getting my point? सही है ना? Okay. Now, what will be the another wave function? Sorry, what will be another boundary condition? You have x at x is equal to a. This must be also vanish because your particle is confined between x between 0 to a, and all other than this thing, the wave function is vanished. So we have xa is equal to 0. So we have C sine kxa must be equal to 0. And you have exactly same quantization rule came from one-dimensional box. So this is just a recreation of one-dimensional box, है ना? फिर से वही चीज सॉल्व कर रहा है. So, but here we will use the quantum number nx pi. Is that nx will be 0? Is that nx will be 0?
No, sir.
No, sir.
No, never. So nx can be is equal to 1, 2, 3, and so on. And so you have kx is equal to nx pi upon a. Deliberately I have given nx because it is associated to x degree of freedom. So it is associated to x degree of freedom. So we can use this particular term. Okay, everyone is comfortable? ठीक है?
Yes, sir.
Okay.
Yes, sir.
And now from here we can also calculate the value of energy for x degree of freedom, है ना? Because in the kx we have 2m ex upon h cut square is nx pi upon a, and from here we can get energy E, and now we can write this energy is E nx, and that value is equal to nx square pi square h cut square upon 2m a square. Everyone is comfortable right now? सही है ना?
Yes, sir.
And now the last part is C. We have to calculate the value of C. So what is your value of C? We have to normalize it because total wave function is normalized, as well as individual wave function associated to independent degree of freedom, that should be also normalized. So what you can go? You can use here the normalization condition mod psi square dx. From where to where? Obviously 0 to a must be equal to 1, and from here c is equal to exactly the same value you will get from the one-dimensional box. So this is nothing but the solving one-dimensional box. So similarly you can also solve for y. So let us try to write the solution for x first, and then we can write the solution for y just from the analogy point of view. So what is xx? And this is normalized. This will be root 2 upon a sine, you can write nx pi x upon a, where x is between 0 to a and 0 otherwise. So what will be yy? क्या होगा yy जरा बताओगे?
Under root 2 by b.
Very good. Under root 2 by b. And here is
Sine
sine ny pi y upon B, Y is between 0 to B and 0 otherwise. So what is your total wave function? The total wave function can be indices by psi nx and psi ny, isn't it? Psi nx and psi ny. And what is this? This will be 2 upon a sine nx pi x upon a 2 upon b sine ny pi y upon b if x is between 0 to a, y is between 0 to b and 0 otherwise, isn't it? Now what is value of nx? 1, 2, 3 and so on. What is value of ny? 1, 2, 3 and so on. Suppose someone will write this nx and ny something like this. Is that he is correct or wrong? अगर कोई इस तरह से लिखता है तो वो सही है या गलत है?
Sir, wrong.
Yes, sir.
Wrong है. He is wrong. Why? Because nx and ny are independent and here you are writing such that they are highly dependent. Means if nx is 1, then ny is also 1. If nx is 2, ny is also 2. But this is not correct. Nx is 1, then ny can be any number between 1 to any positive number. So similarly, you can have this thing. And what will be your energy eigenvalue? E nx ny and that value is equal to nx square upon a square pi square h square upon 2m. Is that okay? ठीक है ना? It's okay?
Yes, sir.
चलो. So अब हमेशा हमें क्या ध्यान में रखना है? जब भी 1 डायमेंशन का सिस्टम का पता है तो 2 डायमेंशन 3 डायमेंशन में हम इजिली लिख सकते हैं. एनर्जी आइगन वैल्यू क्या होगा? डायरेक्ट सम एंड आइगन फंक्शन विल बी डायरेक्ट प्रोडक्ट. ओके, सो लेट्स ट्राई टू डू सम बेसिक क्वेश्चंस. सो अभी से लेके कल की क्लास तक हम लोग सिर्फ प्रॉब्लम ही करेंगे. ठीक है? तो टुडे वी विल ट्राई टू फिनिश this box part and tomorrow we will just try to finish harmonic oscillator part 2D and 3D. चलो, Vxy is equal to 0 if x is between sorry 0 to a and 0 to b, infinity otherwise. Question number 1. Find the average value of x, average value of y, average value of x and y. Question number 2. For b is equal to 2a, find the first 4 energy eigenvalue and associated degeneracy. What is associated degeneracy? For a given energy eigenvalue, you can have more than one eigenfunction. So if this is the case, you can have degeneracy in your calculation, okay, in your system. Third, for B is equal to A, find the energy eigenvalue and associated degeneracy for first 5 level. Fourth question, for B is equal to A, if energy eigenvalue is given as 25 pi square h cut square upon ma square, what will be degeneracy? Okay, what will be degeneracy for this particular level? Chaliye, so let's try to calculate step by step. Okay, so what will be first answer? The expectation value of x. So if you are calculating the expectation value of x, you have to go for x mod psi xy square dx dy, isn't it? Hoga na?
Yes,
And
sir.
if you are writing something like this, and you can go for nx ny, then you can easily write x part together and y part together. So this will be x 2 upon a sine square nx pi x upon a dx 0 to a, and second term is 2 upon b sine square ny pi y b dy 0 to b. So what is this value? What is this integration?
Sir, a by 2.
Hmm?
A by 2.
A by 2. Very good. So this integration is nothing but a by 2. And what about this integration?
Sir, 1.
1. Very good. Because it is normalized and this is expectation value. This is normalization constant, है ना? ये normalize है, इसी कारण इसकी value 1 होगी. And you remember, this is your expectation value of x into one dimension. So this is nothing but a by 2 into 1. Yes. So what will be answer for second one?
B by
b by 2. उसमें क्या हो जाएगा? अगर आप y लेते हो तो ये तो ऐसा रहेगा, यहां आ जाएगा. So this will be 1 into b by 2. अगर आप x and y लेते हो, so x is also there, y is also there. What will be solution? A by 2 into b by 2. So hence x and y are independent. You can independently calculate the expectation value of x and expectation value of y. Isn't it? Okay. So the last one is AB by 4. So now आप देख रहे हो कि किस तरह से वन डायमेंशन का यूज आप बहुत ही इजिली कर पा रहे हो. जो भी आपके वन डायमेंशन आपके प्रॉपर्टीज हैं उसके यूज कर पा रहे हैं, है ना? Now second question, it's a very interesting and very informative also. So let's try to go for second one. चलिए, for the second one, what is b is equal to 2a, isn't it? So what is your energy eigenvalue? I can write E nx ny is equal to nx square by 1 ny square by 4, and that is pi square h cut square upon 2 ma square, and I can write this whole term as something like E naught. Okay, and your nx and ny, you know, they are allowed quantum number. Chaliye. So what will be your ground state energy? What is your ground state energy? The lowest value of energy? Yes, ground state is what? Lowest possible value of energy. So what is lowest possible value of energy here?
5 by
Or
4.
for which quantum number?
Sir, n is equal
is
to
equal
1.
to 1 and y is
So
equal
you
to
have
1.
for 1 and 1. Nx is equal to 1 and ny is equal to 1. So that value is equal to pi by 4 E naught. Am I correct? Now, what will be the next value? 1, 2 or 2, 1?
Sir, 2, 1.
2, 1 और 1, 2? 2, 1 में देखिए कितना आ रहा है?
सर 2, 1 होगा, 1, 2 होगा.
1, 2 होगा, है
Yes,
ना?
sir.
2, 1 is very
Yes.
high. So next value is
sir.
what? E 1, 2. What is this value? क्या हो रहा है? 8 by 4, है ना? 8 by 4 E naught. Isn't it? Yes or no? I deliberately keep denominator same so that we can compare it. Now,
3
Yes,
by
sir.
2.
3 by 2 कैसे होगा?
Sir, nx1.
nx की वैल्यू 1 पुट करो और ny की वैल्यू 2 पुट करो, क्या होगा?
2e0.
सर 2e0 ही आ रहा है.
2 ही नॉट आ रहा है ना, तो उसी को तो 8 by 4 लिखा है मैंने. What is next value? 1, 3 या 2, 1?
सर 1, 3 होगा.
1, 3. What is this 1, 3? कितना आ रहा है?
13 by 4.
That is 13 by 4 E naught. What is your next one? 1, 4 or 2, 1?
2, 1.
And what about 1, 4? What is 2, 1?
17 by 4.
2, 1 is 17 by 4 E naught. And what is next? 1, 2
Sir, 2.
or 2, 2? Sorry, 1, 2 नहीं. 1, 4 and 2, 2. क्या हो रहा है बताइए?
तो 1, 4 में तो 5 आ रहा है सर.
और 2, 2 में क्या आ रहा है?
Same. Same आ रहा है sir.
सेम आ रहा है सर.
सेम आ रहा है.
यस सर.
So what you have?
सर.
You have E22 and E14 have same energy eigenvalue, that is 20 by 4. So what is this? This is degenerate state, isn't it? You have two wave function. One wave function is psi22, another wave function is psi14. These two have same value of energy eigenvalue, and that is 20 by 4 E naught. So this level is doubly degenerate. ये level क्या है ये? Doubly degenerate, isn't it? This level is what? Doubly degenerate. समझ में आ रहा है ये? यस या नो? क्लियर है?
यस सर।
ओके, तो ये घर में जाके प्रैक्टिस करोगे, एग्जाम में आएगा ये। ठीक है, अभी तक आया नहीं है। चलो नेक्स्ट क्वेश्चन बात कर रहे हैं। सो नेक्स्ट, इफ बी इज इक्वल टू ए, ये किस तरह का बॉक्स होगा? स्क्वायर बॉक्स ना?
यस
नेक्स्ट
सर, स्क्वायर होगा।
कैसा बॉक्स होगा? स्क्वायर बॉक्स होगा। सो इफ यू हैव बी इज इक्वल टू ए, that means you are talking about square box. So what you have? So B is equal to A. What is your ENX and NY? ENX and Y is equal to NX square plus NY square is equal to pi square H cut square upon 2m A square. Now what will be your ground state? 1 0?
2
Huh? 1 0?
1
No,
1.
1 1.
No,
One.
never 1 0. This is 1 and 1. So that value is 2 E naught. I can put this number is E naught. Okay. Next, what is next one? E12 या 21 or both?
Both.
Both.
सर
So
बोथ।
E12 is equal to E21 is equal to what? क्या होगा? बताइए क्या होगा?
5.
5 V naught.
सर 5 इनर।
5 E naught. Very good. Next, E13 or E22?
2 2 sir. 2 to 8 is
8. 22 is 8. 13 is something else.
9.
Huh?
10.
10. So next
10.
is 2 and 2. And this is what you can see. E12 and 21 is what? Doubly degenerate. So degeneracy को आप G से लिखते हो, that is 2. Here degeneracy is equal to 1, not 0. E22, what is this value? 8 E naught. है ना? What is degeneracy? Degeneracy is equal to 1. Next,
1 3.
1 3.
3 3 1
And
भी
3
होगा।
1 is also there.
Yes.
कितना आ रहा है ये?
10 E naught.
10 E naught. Degeneracy is 2.
2.
तो क्या ऐसा लग रहा है क्या या तो 2 होगा या तो 1 होगा? ऐसा ही होगा क्या?
Yes,
ऐसा
sir.
नहीं होगा, है ना? लेट्स कम टू
2 3.
नेक्स्ट प्रॉब्लम। नेक्स्ट प्रॉब्लम में जब आप आ रहे हो तो इस तरह से आप कैलकुलेट कर सकते हो किसी भी लेवल का, एंड देयर इज नॉट एनी फॉर्मूला। ओके, यू हैव टू जस्ट चेक स्टेप बाय स्टेप। चलो, देयर आर सम in some cases there are formula, but some cases you have to check. Now for the square box, what will be energy given to you? क्या एनर्जी दिया हुआ है? 25 pi square h cut square upon ma square. So you have to calculate the degeneracy for this particular level. इस लेवल के लिए आपको क्या कैलकुलेट करना है? degeneracy. So now can you calculate the degeneracy for this level? So you have to calculate, if you want to calculate the degeneracy, mainly you have to calculate the nx and ny, different composition of nx and ny, such that you are getting the same number. So now can you please tell me what is your nx square plus ny square here? क्या होगा?
50 sir.
50 या 20 या 25?
50.
50.
50. Why? Because you have to write in a correct form. So you have to divide with 2. So you have to multiply it with 2. So this is your 50. Okay. And what is constraint? That nx and ny, and nx square plus ny square must be 50, and nx and ny must be positive integer. So this is our constraint. So now I am putting nx and y. So is that nx is 1? So what is ny can be there?
7.
7.
7
Okay. Is that nx can be 2? nx की वैल्यू 2 हो सकती क्या?
No.
No. If nx is equal to 2, then ny will be fraction. है ना?
Yes, sir.
Yes. Is that nx is equal to 3?
No, sir.
No. If nx is 3, then ny is again fraction. Ny, if nx is 4, ny is again fraction. Now, if nx is 5, what should be ny?
5.
Hi.
5. So you have 5 and 5. Nx cannot be 6,
6.
isn't it? The next level is what? 7 and 1.
1.
So, how many different sets of nx and ny can be created here?
3.
3 set. So, what is degeneracy? 3.
2.
Triply degenerate in this case. You have triply degenerate. Clear है ये? ठीक है ना? Okay. चलो.
Yes, sir.
Let's try to go for one more problem. Vx y is equal to 0 if x is between 0 to a, y is between 0 to a, and infinity otherwise. And infinity otherwise. Now, if E naught is ground state, सोच करके रखना. If E naught is ground state, then what is value of third excited state? Third excited state. What is value of third excited state? क्या होगा value third excited state का? If E naught is ground state. कैसे solve करोगे? So what is your E, Nx and Ny? Nx and Ny is equal to what? Nx square plus Ny square, and this is your pi square h cut square upon 2 ma square. So what is for ground state? E11, and this value is equal to क्या मिल रहा है ये? 2 pi square h cut square upon 2 ma square is equal to E naught. इस पूरे की वैल्यू हमें क्या मिल रही है? E naught. So what is my pi square h cut square upon? So these are our parameter. We have calculated. We are just going to calculate the parameter. Pi square h cut square by ma square, and this value is equal to what? E naught. है ना? इसकी वैल्यू कितनी हो रही है? E naught. Now, what is your first excited state?
1, 2.
So this is your EG. EG. What is your first excited state? 2, 1 is equal to 1, 2. This is your EF, first excited state. हमें third तक जाना है. What is your second excited state? E 2, 2. What is your third excited state? बताइए क्या होगा?
1, 3 and
E 1, 3 and E 3, 1. यही है ना? So what is this value? 9 plus 1 pi square h cut square upon 2 ma square, isn't it? And this value is equal to, ये जो value मिल रहा है, that is 10 by 2 pi square h cut square upon ma square. And what is pi square h cut square upon ma square की value कितनी है?
E naught.
E naught. So that value is equal to what? 5
5
E
winner.
naught. So your third excited state will be 5 E naught. तो ये इस तरह के क्वेश्चंस खूब एग्जाम में आते हैं, ठीक है, मेनली गेट के एग्जाम में एंड योर आईआईटी जैम. आईआईटी जैम का तो फेवरेट है. सो दिस आर द मेथड हाउ यू कैन यूज क्वांटम नंबर एंड हाउ यू कैन यूज पैरामीटर्स. ये दोनों चीजों को आपको ध्यान में रखना है एंड योर फोकस इज मेनली ऑन डिजेनरेसी. एंड यस,
फोर्थ पूछता तो 2 3 लेते ना.
क्या
फोर्थ पूछता तो 2 3 लेते ना सर.
फोर्थ, क्या सेकंड, थर्ड एंड
Yes,
फोर्थ, इसके
yes,
बाद
sir.
वाला, इसके
Fourth.
बाद वाला कौन आएगा?
यस सर. 2
देखो
3
2 3 आएगा या 1 4 आएगा?
16 17 आ रहा है.
कितना 1 4 में कितना आएगा? 17.
17
और
और
2 3 में कितना आ रहा है?
13.
13. तो 2 3 होगा, है ना? ओके, सो यू हैव टू जस्ट गो फॉर लेवल बाय लेवल. ग्राउंड मीन्स मिनिमम फंडामेंटल. फर्स्ट मीन्स ग्राउंड के जस्ट नेक्स्ट वाला. सेकंड मीन्स उसके नेक्स्ट वाला, एंड सो ऑन. आर गेटिंग माय पॉइंट?
यस सर.
यस या नो, है ना?
Yes,
Yes,
sir.
sir.
Okay. So I think you have get all the concept right now. आप इसको रिवाइज करो and tomorrow we will finish this particular topic and tomorrow we will also finish the JAM examination के topic तक को हम लोग cover कर लेंगे and after then we will go for our next level that is mainly advanced level. So again I will come back for the harmonic oscillator with the operator method and some more mathematical work in a postulates and then we will go for angular momentum algebra. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you.